Vodcast 7.4 is a little bit more about Vodcast 7.3. We're going to review the types of reactions. I'm going to give you some more examples. We're going to look back at some of our worksheets. So if you have your worksheets, especially 2 and 3 handy, you might want to grab those, as well as the back of the notes that you took for 7.3, that big data table. I'm going to give you a couple more notes and some examples on some of the different types of reactions. First, we're going to talk about decomposition reactions. Decomposition, for our purposes, the products of a decomposition are going to be the elements that make up the reactant in their standard state. So how do you recognize a decomposition reaction? You only have one reactant. If you look at worksheet 3, question number 2, in the presence of chlorine gas, solid potassium iodide. Here I only have one reactant. One reactant breaks up into its element, potassium. How do I know potassium is a solid? If you look at the periodic table, in its standard state, it's a solid, as is iodine. Yi2, don't forget about your Brinkelhoffs. Another example, same worksheet, worksheet 3, number 4. Here I have iron hydroxide. This is a decomposition reaction because I have one reactant and it's breaking down into 2 or more products. Synthesis reaction. For our purposes, the product of a synthesis reaction is going to be one compound. So how to recognize a synthesis reaction? You have one product and only one product, and it's a combination that includes all of the reactants. This product is of all the reactants in their common oxidation state, or their most common charge when you balance them out. So let's go back to worksheet 2. There's lots of examples of synthesis on worksheet 2. Going to number 7. Here's number 7. Carbon plus sulfur goes to carbon disulfide. Why carbon disulfide? Well, carbon, if you look on the periodic table, can be a plus or minus 4, and sulfur is a minus 2. So we balance those out, and it's CS2. Combustion. How do you recognize a combustion reaction? A combustion reaction is when you have oxygen as one of your reactants. Whenever you see oxygen as one of the reactants, it's going to be a combustion reaction. If it's something organic or it's a hydrocarbon, you're always going to produce carbon dioxide and water. Again, if you flip back to worksheet 2, here are several examples. Here's O2. This is also a synthesis reaction because I have 2 things becoming one product. Here I have 2 things becoming one product. That's a synthesis. It's also a combustion. How do I know? There's oxygen. Going down further, combustion with an O2, synthesis, 2 things becoming one product. A little bit more on displacement reactions. First, single displacement. Single displacement. You have one single, usually a solid metal reactant. It's going to kick out one of these, in this case B, the positive part, or the cation. It's going to kick out the cation, which is in an aqueous ionic solution. So you can have 2 possible scenarios for single displacement reaction. You can have a gas emitted, or you can have metal plating. I'll give you 2 examples. But first, how do we know that this is actually going to happen? You have to use this thing called the activity series. Here's what it looks like. This is what the activity series is. Single displacement reactions can be predicted. The more active elements displace the less active elements. So, the thing that's by itself has to be higher on this list than the thing that it's going to displace. It cannot displace an element that's going to be below it. So here are 2 examples. Here was my solid zinc, and I had hydrochloric acid. So this single metal is going to kick out my cation. Here's hydrogen gas, and that leaves the zinc to bond with the chloride. How do I know in this reaction that it's emission of a gas? Well, we spit out a gas. How do you know hydrogen's a gas? In its standard state on the periodic table, hydrogen is listed as a gas. So I can have single displacement where I kick out B and B is a gas. Or I could have metal plating. This was the example you saw in 7.3. The lady in the video had copper wire. She put it in a solution of silver nitrate. The copper kicked out the silver. You had silver metal. She shook the little tube. You had silver metal being produced. And how do you know this is metal plating? Well, silver, in its standard state, is a solid. So what's left? You had silver all by itself. Then the copper is left to bond with the nitrate. Why is this CuNO3 2? Well, we know NO3 has a 1- charge. Copper, in its standard state, can be +2. Drop and swap, balance these guys out. CuNO3 2. Again, here's the activity series. This table will always be given to you. How do we know those reactions are going to occur? Well, we had zinc reacting with hydrogen gas. Zinc was all by itself. Zinc has to be higher on this activity series table than hydrogen in order for the reaction to occur. So it will occur because zinc is way up here and hydrogen is down here. The other one, copper and silver, here's copper, here's silver. Will copper kick out the silver? Copper all by itself, higher than silver? Yes, that reaction will also occur. Here's some for you to predict. Pause the video now, answer these, go back and use that table, and we'll go over this at our next class. We'll continue on with double displacement reactions. Double displacement, you have the same swap. In this case, you have 2 ionic solutions. You have cation, anion here, and cation, anion here. They're both going to switch places. The A and the C, it's a double swap. So instead of one kicking the other out, they're going to double swap places. So the C will bond with the B, here it is, and the A will kick out the C, bond with the D. Both reactants are ionic compounds. Both reactants are aqueous unless, or both reactants are aqueous, true. Both products can be aqueous, but sometimes you get a precipitate. What's a precipitate? Something that's solid. You saw this on the video. You saw this in the lab, the station C, where you had the yellow solution and the clear solution. Sometimes they're both solutions, but sometimes a precipitate forms. A precipitate forms when you have something that is insoluble. What does insoluble mean? Does not dissolve. So double displacement reactions always occur. Sometimes they're soluble and sometimes you form a precipitate when it doesn't dissolve. For now, you will be told what solid product is. In a later unit, you're going to be given a list of what we call solubility rules. and then you can predict which ones are going to be aqueous and which ones are going to be solid. But for now, you'll be told what the product is. I'll tell you if it's a solid or if it's an aqueous solution. So single displacement. Only for single displacement do you use the activity series. A reaction may occur, a reaction may not occur. You're either going to have gas emitted or you're going to have metal plating. Double displacement reactions always occur. You have two ionic solutions, you get the double switch, and for now you will be told if you get a precipitate, if you have a solid. Neutralization, we did this in Vodcast 7.3. Neutralization is a form of double displacement. Double displacement that you always form water and some kind of salt. We can go back to the worksheet 2 and pick out some examples here. Looking for water as a product. Here's an H. Here's an OH. I'm at number 3. I form water right here. This is a neutralization, but also a double displacement reaction. Scrolling down, number 10, H, OH. Here's water. Has to be a neutralization and a double displacement as well. H, OH, water, neutralization, double displacement. H, OH, there's a lot. Neutralization, double displacement. H, OH, neutralization, double displacement. Here's your water. 15, what type of reaction would this be? I only have one product. One product equals a synthesis reaction. You can check on the back. One product, synthesis. One product, synthesis. What's happening here? I see an O2. An O2 means combustion. Here's another one, O2, combustion. O2, combustion. H, OH, water, neutralization, double displacement. H, OH, water, neutralization, double displacement. One product. One product is a synthesis reaction. One product is a synthesis reaction. Feel free to go back in this worksheet. You can label all of them if you want. It'll help you practice your reaction types. And what are you going to have to be able to do? For the test for this unit, you're going to have to write a balanced equation from words to symbols. Include all appropriate symbols, so the solid, the liquid, the gas, the states as well, a standard state of the elements. You have to know your ions so you can swap and drop. You'll be able to list or identify the type of reaction. Is it a synthesis, decomp, combustion, single displacement, double displacement, or neutralization reaction? And then you're also have to be able to use the ratios of the reactants and the products and sometimes the energy to solve basic conversion problems. So grams to moles, use the mole ratio. This right here is called stoichiometry. We're going to take this to one more level next unit when we talk about limiting reactants and percent yield. But for now, writing a balanced equation, balancing the actual equation, listing the type of reaction, the standard states, and mole conversions is what the Unit 7 test will be on.